Hi everybody, Derek Runberg here with Sparkfun Electronics, and today we're going to take a deep dive into programming and using the microbit using Microsoft MakeCode. So with that, I have a few slides I want to show you first before we jump into programming, a little bit of background as well as the different bits and pieces of the microbit. So a little bit about the microbit if you've never heard of it or seen it. It's a pocket-sized computer that empowers students. It's designed for student use for them to learn programming in a physical and tangible way. When you pick up a microbit, you'll notice that it has a lot of bits and different pieces. It has what I call the world's worst monitor, so 25 total pixels, no 1080p or fake 4K here, 25 5x5 array. It has two buttons, an A button and a B button. A reset button on the back to restart your programs, similar to a reset button on an old video game console or old computer. Has an accelerometer on it, so it knows which way is up, down, left, right, or if you shake it or throw it across the room. It has a compass on it, so it knows which way is north, south, east, west. Has Bluetooth on it in terms of a radio, so you can have two microbits talk to one another. And then one of my favorite things is this edge connector that allows me to plug it into a number of different breakout boards and build circuits with it. So more advanced use case in that situation. We're not going to cover anything in this webinar or this video, but we are going to explore it more in other videos in the future. So let's get our hands dirty. If you want to access these slides that I'm going over, which has step-by-step instructions and for coding all of these examples, as well as more background information, the link is right there. We're also going to be using Microsoft MakeCode to program our microbit. So you can find it there as makecode.microbit.org. Okay, we've landed at the MakeCode website, makecode.microbit.org, and it's presented as essentially your own little landing page with all of your different projects laid out here. I've started one, but I'm going to start a new one for demonstration purposes. And I'm presented with my programming environment. This is broken into roughly three different parts. My work surface or my programming area, where I can drag and drop all of my programming blocks, and we'll use that to build all of our programs for microbit over the next hour or so. We get all those blocks from the drawers. So if I want to open a drawer, I click on it, and I can select any number of programming blocks to build my program. They're all color-coded, so if you ever see a program that you want to reproduce or you're curious about, you can actually look at the color of the block and then go find it in its constituent drawer. You can actually also search at the very top. So if you see the name of a block, but you can't find it anywhere, you can actually type it in the search bar and it will show up. Such as, let's try this one, show, and now I can find show LEDs, show string, show number, and so forth. So search is a very powerful tool. Last but not least, there's a simulator on the far left. This will show and simulate any code that we create in MakeCode without having to download it to our microbit. So if, for example, if you don't have a microbit on hand right now, or you just don't feel like getting it out, you can actually test some code out using the simulator. Let's jump in and do our first program with the microbit. Okay, so I've switched my camera to my microbit in real time, so we are going to be able to see when we upload it to the microbit here, as well as the simulator. When jumping into MakeCode in the microbit, one of the first things that I like to get students working, get up and working, is using the LEDs. They're probably the easiest output to start controlling. It's also the most exciting and interest capturing part of the microbit. To use the LEDs, the first thing we do, it's actually underneath basics, and it's the show LED block. Now, when I click bring it out, it shows up gray until I place it in either the on start or forever. The difference between these two blocks is the on start, whatever code I put inside of on start, will run once and only once when I turn on the microbit, either by uploading code or plugging it in a USB cable. It's only going to happen once at the beginning of that program. If I put it in forever, it will loop over and over and over and over again, well, forever. So I'm actually going to place it inside of Forever now. And I'm going to create a basic image, a self-portrait. Now it shows up in the simulator here on the left. Yay, smiley face. And that's it. That's my first program. I created some basic art, some pixel art, and it's actually a very popular thing for students right now with the advent of Minecraft and some of these other block-based, blocky games that uses kind of this pixel idea. And they can change their designs however they want, and it will update in the simulator. Very, very basic. Just let them play around with it for a good 5 minutes or so. And then the next thing is, how do I take a drawing or an image and make it an animation? You can talk about an animation as a series of images or series of pictures. Well, to create an animation in MakeCode, all I have to do is create a series of show LEDs. And so I'll take another show LED block, drag it in, and I am going to make a second image that is slightly different than the first one. And you'll see here in the simulator, now it's a talking self-image animation because it shows this block and then it shows the second one and then it loops. It's a forever loop, so it loops back to the top, the mouth being open, mouth being closed, over and over and over again. So we have our animation just how we want it with the two different smiley face images. It's working as we would expect in the simulator. It's now time to get it on our microbit. We do this through downloading that code to the microbit. And what MakeCode does is take these blocks and which is something that's easy for us as humans to read and see, and turns it into what's called machine language, which is a hex file, a .hex file. And then it downloads it to the microbit itself, and then the microbit starts to execute those instructions. A little too much detail for now, but just so you know, in case a student asks, is that's how it works, is that the computer takes something easy for humans to read, turns it into something very hard for us to read, ones and zeros, and then downloads it to the microbit. The first thing we need to do is pair the microbit to our laptop. So that our laptop and MakeCode knows that that is a specific microbit we're programming. So the download button here, next to it is these three little dots. We're going to click on that, and we're going to click Pair Device. Gives us some instructions. Connect the microbit with a USB cable. Done that already. We need to pair it. And so we're going to actually click Pair Device. If for some reason you don't see this, the help documentation for MakeCode is super helpful. It'll tell you how to fix the problem if there's a problem in terms of you might need to update your firmware or something like that on your microbit, and it gives you the exact firmware file that you need to put on there. So you don't need to worry about that at all. But for now, we're going to click Pair Device, and it gives me a list of devices that I have to choose from. There's only one, so I'm going to click Microbit, and I'm going to click Connect. Once it's connected and it sees my microbit, you'll see right here, now the download icon's changed to a USB icon. And all I have to do now is click Download. And what will happen is, if I flip over the microbit, you'll see that this LED on the back is blinking, which means all of that machine language code is being pushed into the microbit. And now my animation is happening on the microbit. So from this point forward, once I have everything paired with my laptop, all I have to do is click Download to get that onto my microbit as long as it's attached via USB. Now, if I take this microbit and I go plug it into a different laptop, I still need to go through that pairing process each time that I change machines or computers. So just remember that with your students. If they're using different microbits with different laptops, they're going to have to just kind of get used to the pairing process. As you saw, it was relatively painless, but it is going to be part of their learning process as they come into a computer lab, probably get assigned to different computers or different microbits each day. With that, let's jump forward into exploring MakeCode a little bit more. With our animation on the microbit, it's a good time to talk about outputs and inputs. So something that is the microbit, it physically is doing itself. So turning something on or off is an output. So this is actually turning LEDs on and off in a sequence. in an animation, and that is an output. You can think of a monitor for a computer as an output. You can think of audio or sound as an output. We have motors hooked up to this if we wanted to. Those would be outputs. We're telling the microbit to do something. The next step is to talk about really basic inputs. And they have an entire drawer full of inputs, blocks that we can use. The first input that I like to use is the buttons that are on the microbit itself. So I can bring in a button block, and you'll notice it's a little different than the show LEDs block. It's similar to the forever non-start, and this is called an event block. So inputs can be broken into two different things. It can be kind of like a raw variable input that we can talk about, we'll talk about a little bit later, or an event block, which is something that is more binary or on or off. And it is just what it is. It's an event. When something happens, it will trigger a group of code. So for example, if the button A is pressed on the microbit, something will happen. The project that I like to kind of lead students through with these buttons first is a thumbs up, thumbs down, yes, no machine. So in other words, we've all used those thumbs up if you've got the answer correct, thumbs down if you got it wrong, or thumbs up if you have this opinion, or down. I like to create that with a microbit. This also gives us an opportunity to teach about the icon block. The icon block is nothing more than pre-drawn images or icons for the LED array. So on button A pressed, I want the show icon to show a check mark or a yes. When button B is pressed, and again, I can only have, I'm going to stop here, but you can only have one button A pressed event block. Notice that both of these say A, one of them is grayed out. Once I change this to B, I'm good to go. Both of them have color, and I can add an icon for what button B is. But a lot of people get hung up the first time they bring in a second block. It's gray. What does this mean? We can only just have one event for each button. So I'm going to select button B. And my icon for this is going to be my negative response, an X or no. So again, let's try this out in our simulator. So if I ask the question of, was your weekend awesome or not? I can hit yes, or I can hit no. So it works on our simulator just fine. And we're going to get this onto our microbit and test it out. So I'm going to click download again. And I'm going to show in folder. And I'm going to drag and drop this again to my microbit drive. Copies the file over to the microbit. Now, the microbit itself won't do anything right away. But if I ask the question, are you going to have a fun weekend this weekend, or did you have a fun weekend this weekend? And I can click yes or no. And I can go back and forth answering the different questions. If you had a question that needed a third answer, or if you ever teach middle schoolers, this is the meh answer, it's the cop-out answer. We can actually use both buttons simultaneously, button A and B. And let's again use the icon instead. What's a good kind of in between? Yeah, right there. Sleep. Perfect middle school answer. So now I have A, B, and the simulator, since I can't press both of them with my mouse, gives me kind of this fake A plus B button of asleep. I don't need to download this to my microbit, but you can get the idea of three different options. With our three different options in terms of inputs, a great time in this point is to play a game with your students. Right? We're going to put this to good use other than answering questions in class. Let's build rock, paper, scissors. And so that it's an avenue for students to do some programming, but then get up, play one another, have some fun, be a little get up and be physical rather than just sitting at a computer. Even though you're programming something physical, it's always good to have applications that get students up and moving. Great thing is this example takes very little change to what we have here. It does bring into account one addition, and that is on shake. The first thing I want to do is I'm going to change my icons rather than check X and sleepy face. I'm going to change my A button to rock. And a number of people have different options about what the icon for rock is. I like to use chessboard. To me, this looks like a rock. B is paper. So we're actually going to change that to a piece of paper or square. And then A plus B is going to be our scissors. And thank you, Microsoft MakeCode team, for including scissors, because I don't know if I'd be able to draw my own or figure out which one to use. So I'm going to use scissors there. So we have rock, paper, scissors. So now I can go 1, 2, 3, rock, paper, scissors, go, and I get rock. Paper, and if I press both of them, it'll be scissors. So students can get up again with a battery pack or even with a USB cable still attached. Go rock, 1, 2, 3, go. And they choose which one they want to do, rock, paper, scissors. I like to add another input event block here, and that is to clear this screen of their previous input. They treat it like an Etch-a-Sketch. Now, you might have to explain to your students what an Etch-a-Sketch is, but what we want to have happen is that when they shake the microbit, it clears the current icon. So with that being said, we need to find the clear screen or clear block. Now it's kind of buried in the basics, so it's actually in the second drawer or more of clear screen. I use this actually as a really good opportunity to teach and kind of force students to use the search bar and type in clear, and then we'll find the clear screen. Especially for me when I'm teaching, I don't want to have to click and click and click again to get kind of pretty deep. So again, using that search bar is great. So now I have rock, paper, scissors, and then I shake it to clear the icon. Let's try this in the simulator. Rock, and then I can either click shake up here, or I can actually physically shake it for it to clear. Paper, scissors. I'm actually going to download this to my microbit. Because the first time your students use the shake, they're going to grab this thing by the USB cable and go absolutely nuts with this. So one of the best ways or descriptions I use for the type of shake that you're looking for is a ketchup bottle shake. So again, I'm going to do A, there's my rock, ketchup bottle shake, empty. Paper, ketchup bottle shake, done. Both buttons, do this one-handed. There's my scissors, shake, clear. So that's rock, paper, scissors. It is so fun to get up and have a rock, paper, scissors tournament with your class. And when the last 2 people are up, play the Rocky theme song and make a big deal of it, do a best out of 3, and have something for the winner, or maybe they get to leave early or something like that, a minute early. But it's just really fun to really make a big deal of it and have fun with your students with rock, paper, scissors on the microbit. Okay, we've played rock, paper, scissors, gotten used to inputs in terms of event blocks. We've done shake, we've used icons. And now in terms of learning and incorporating the microbit into some other topics around class, math is a really good place to start to incorporate the microbit if you're looking to really span outside of programming and computer science or something just like the Hour of Code into using this day to day with your students. One place that I have actually found that has a lot of value here in math is the idea of probability and the idea behind flipping a coin. And so one of the things I really enjoyed programming with my students with this was, let's program the microbit to be our coin, that we can actually flip it or flip a digital coin and it will either show heads or tails. So I'm actually going to clean up my workspace here because we're going to use the onShake event to start with, but we're going to get rid of everything else. And so for me to clear blocks, all I have to do, I can click on something and hit delete, but I can also drag it over to the drawers and it will delete on its own. So onShake, what we want to do is we want to, when we shake our microbit, we want it to show a quick animation, and we'll go over kind of what that animation looks like that symbolizes a coin being flipped. And you can leave that up to your students. It gives them a little bit of area to be creative in this beyond what they would probably feel is rather sterile math side of things. So one, they're going to create an animation when this thing is shaken, and then it goes into the functionality of generating a random number, and then depending on what that random number is, show either heads or tails. And they can come up with also what heads icon is and what the tails icon is. So with that being said, we're going to create the animation first. So onShake, and we're actually going to use a loop. So I'm going to say repeat. So I'm going to click on loops, repeat, and we're actually going to repeat it twice. So instead of, it's going to be a short repeat loop. It's not going to be 4. What we want to have it do twice is we want it to show a couple of icons. So the first one is a small diamond, and then the second one is the large diamond. And to me, this is what it looks like if you were to, and I'll run it on the simulator here, like the idea of a coin flipping over and over again in the air. So we can actually increase this number of times if we wanted to. Let's do it 3 times. And now if I shake this, coin's flipping, building drama, and then nothing happens yet. So there's the animation. It should be relatively familiar for your students. Again, we're incorporating the repeat block to make this as efficient as possible. Next thing is we want to generate a random number and store it in a variable. So you can talk about variables with your students a little bit. They've probably been using them, but you maybe not have named them as a variable. They've been using X or Y or Z. But now it gives you some time or an opportunity to put the idea of a variable to use in that. All it is, especially in computer science and programming, is that it's a bucket for storing information. And so what we're going to do is we're going to generate a number and then store that number. So we're going to make a variable, and we get to name this. And I'm going to name it flip. Your students will ask, hey, can I name it bananas? Can I name it John? Can I name it screwdriver? The answer to that is yes, you can. But in the end, we want our variables to really define and describe what they're storing. It's like putting labels on leftovers in the refrigerator. We want to make sure that they're accurate so that someone hungry for leftover hamburger doesn't end up eating leftover salad. Neither one of those sound that bad, but you get the idea. So I'm going to name it flip, and it actually then incorporates, or it creates, a number of blocks. So I can actually flip itself in terms of a variable, and then set flip to, and that's the block that we want. So after it repeats this animation, we're going to set flip to a specific number. And that number is going to be a random number between 0 and 1, so 2 choices. And that's under math. And so we're going to click on math, and there's all these different math functions. We're going to pick random, 0 to 10. And we actually want 0 to 1. We want 2 options. Now we need to do something with this variable. So we've created that variable. We've set it to a random number every time this thing shakes. Now we need to do some logic around it. So I'm going to say logic. And we're going to say if. It's going to go right after this coin flip. We have to build a statement. So an if statement is like playing Simon Says with the microbit. And the microbit will always win. It's always going to do what Simon says. So when we play Simon Says, you have to have the qualifying statement of Simon says. It's similar to what this true-false statement is, or this statement at the top. If that statement that we're going to build and put in there is true, then the code will do whatever we put inside of here. If it's false, it will move on. So we have to build this statement. And so underneath logic, we are going to grab equivalency. And any of these blocks that have pointed ends to them are these logic-based blocks. So if something equals something, then do something else. If we need to grab flip is equal to 0, we want to show the icon. And again, this is for heads. Let's see here. Perfect. Skull. So if flip equals 0, show skull. Now here's the thing. I can put another if statement here down below that says if flip equals 1, show something else. Or I can click this plus, which is else. So if this is true, 0 or 1, so if it's 0, show skull, else show something else. So in other words, the only else here is a 1. And this is a great thing, a great lesson about programming and computer science, is that there's multiple ways to solve problems or create solutions. I can use two if statements in this situation, or I can use an if-else statement. I'm going to show the if-else. So I'm going to go basic, show icon, and now I got a creative choice of what a tails is here. And this looks like a snake. Perfect. So if flip is equal to 0, show skull, else show the snake. So let's see here. Shake, coin flip, and tails. Shake again, coin flip, heads. Coin flip, tails. Now, it is much easier to do this and probably logistically easier to bring in a bunch of pennies and have your students flip coins. But this is also an opportunity to go deeper and learn about probability and random numbers and the idea of random from a programming standpoint as well. So you're killing multiple birds with one stone here. So the argument could be made, you probably put in the same amount of time and same amount of effort, and you actually your students end up learning more in the long run of dealing with random numbers and some logic in terms of if else. If you had younger students and you wanted to back this up a little bit, you could even spend a day with flipping coins, physical coins, and teaching them if else in terms of if you flip a coin and say if it's heads, we're all going to run to that side of the room. And you flip a coin, it's tails, what do? They stay put. If it's heads, run to the other side of the room. So they start to learn some of this logic in terms of if else. Then you can move into let's do this on the microbit. And they're building kind of this understanding of some computational logic and computational thought along with this. So with that, I'm going to actually download this to my microbit. And now we can test it. I can give it a quick shake, animation, and heads. Shake it again, coin flip, tails. There's a number of extensions that we can do here with the microbit in this program. We can transition from this being a coin flip to rolling a dice, and incorporating if else statements and expanding on that with instead of 0 to 1, it's 0 to 5, so it's a 6-sided dice. And then you kind of have cascading if statements of if it's equal to 0, show a 1, so on and so forth, all the way down. You can also have this record how many times, so create more variables, and for each time that it hits heads, that you increase a heads variable by 1, or you increase a tails variable by 1. In fact, let's do that. Let's jump into that. We're going to do a really quick example of taking this a little bit further and having the microbit count those two. So here's this basic, the flip and the flip variables. Let's create a heads and tails variable and go from there. So we're going to go variables, make variable, and we're going to say heads. Now we have a heads variable. We're going to say tails. Okay, so we've created two more variables. Now, if we want to increase or we want to track heads and tails in this program, we have this change tails and we can select change heads by 1. We're actually going to drag this over. So right here, flip equals 0, it shows heads. Well, I'm going to change heads by 1. And I'm going to do the same thing for tails. Set tails. Oop, not set. I want change tails by 1. So now I have heads, tails, change tails by 1. Well, that's all fine and dandy, but now I have to figure out how to show or display that. So I'm going to grab another input here. On button A pressed, I want it to display as a number how many heads have I flipped. So we're going to go basics, again, show number. And what number do we want to display? We're going to go variables, heads. So now I can shake this to flip a coin. And then if I want to know how many heads I've flipped, I can press the A button. And then I can do the same thing for the B button. Show numbers again. And what number I want the tails variable. Okay. Let's try this out in the simulator, make sure it works. So I'm going to shake it. Again, I get a heads, shake it again, just to get a few data points here. Tails. Tails. Now, if I go over here and I press this, this should be a 1. And I got 2 tails, I believe. 2. With this model, I probably would challenge my students to then, if I pressed A and B, display the total number of flips I've done over time. If they wanted to reset this or change this, they could hit the reset button on the back of their microbit. It will clear all variables and we can start afresh. So with that, that's the coin flip option, and it starts to use some random numbers and variables and if statements. There's a lot in here, but like I said, you can actually be leveling up your students as things go along. Okay, as I mentioned before, the idea of taking this from a coin flip to a dice. And that's actually pretty simple. And so I decided, let's just add that. Let's dive into this and try it. And so I'm actually going to zoom out a little bit so we get some room. And what this incorporates, instead of flip, and I'm not actually going to change the name of this, but let's just say it's a 6-sided coin in terms of flips. Let's create a new variable. I'm going to call it roll. It's a dice. I need to abide by my own rules and have a variable describe what we're doing. So we're going to say roll. And we're going to actually change, instead of flip, we're going to change this to roll. And it's going to pick a number between 0 to 5. So it's a 6-sided dice, 0 to 5. 0 counts as 1. If roll is equal to 0, in other words, a 1, and I'm going to grab these other blocks and remove them. We want it to show, we're going to say show LEDs, 1. So this is going to get long pretty quickly. So 1, now I have more than one option here. I need more than one option. I need actually 6 options, and we're going to add something to this if else statement. So we're actually going to click plus. Notice it brings in an else if then. So it allows me to bring in another logic statement. Logic. I'm going to bring in again the rule variable. And I'm going to say 1, which computer counting is 2. I could go over and grab the basic and bring in show LEDs, but I can also right-click, duplicate, and bring that here. And I'm going to actually do something like this. And we can go all the way down in terms of else-if statements. Again, duplicating even our logic statements so that our work is more efficient here. So 2, I'm going to duplicate it again. 3, need more else-ifs. Duplicate. 4, and then we actually can assume that the last one would be 5. So we can then bring in our show LEDs. This is 3, so I'm going to go like that. Oops. Duplicate. This is 4, so I need 4 LEDs. If I remember right on a dice, it looks something like that. This last one is 5, which will look something like this. My 5 is like that. I'm going to change my 4. That. And my last one, again, assuming, so the else would be 6. So this has the same animation in terms of something being rolled. We set the roll variable to 0 to 5, and then depending on what that outcome is in the else ifs, it will display something. So I'm actually going to shake this. Rolls 4. Shake it again. 4. Shake it again. 2. So again, this just, it takes that if else if statements and gives a logical growth to that concept for students. So from a coin flip, that's just an if else statement to now incorporating an else if for more than 2 options is pretty good. We can also be tracking whether, instead of heads or tails with the A button or B button, whether something is even or odd. There's a number of things that we can use the microbit for to track these things. Even if it's, let's say that value's odd, do something else. So again, it's a really good scaffold to just display the dice numbers, but then be thinking of creative ways for your students to use that in a different way other than just displaying the dice. Because obviously we can just roll dice, have fun doing that like we've been doing for years and years and years in school. But how can we make it richer? How can we make it deeper and learn a lot of things at once? Okay, as you can see, moved on from the dice example and have a fresh new program in front of us with an OnStart and forever. Early on when we were talking about inputs, I talked about events as well as more of this analog variable type inputs, and one of those is temperature. So the microbit actually has a temperature sensor on it. It's on the back, and it's actually part of the microcontroller itself, the processor here. So that the temperature, it can detect temperature, but if you've ever had a laptop on your lap for any given amount of time, or you've maybe if you have a tower or gaming computer, you've put your knee up against your computer and it's a little warm. So we know that computers put off heat and generate heat as they go through their systems, or as they go through their process. So the same is true for microcontrollers as well, the type of computer chip that the microbit uses. It actually puts off a little bit of heat over time. And so the temperature reading that we get from a microbit is, I would say, relatively accurate in that we can see temperature change, we can see if something's getting colder or warmer. But if we wanted to know the exact temperature in the room using the microbit, this is going to be off a couple degrees. It reads out in Celsius, which for those of you using Fahrenheit, it's actually kind of fun to have your students figure out the mathematical equation and make code for it to display Fahrenheit rather than Celsius. But we can use it also as a variable for some interesting programming projects. So first thing we're going to do is that we're going to actually have the microbit display the temperature so that we have an idea of what the temperature is at this current moment in terms of the microbit reading of the temperature. So first thing is we're going to do is we're going to say basic. We used it before, but we're going to use the show number block. We're going to put this in forever. So in other words, we're just programming the microbit display, and we're going to see it scroll by what the temperature is. And we get that variable input from the input block. So we can actually scroll down here. You can see a number of other things that we can look at. We can look at compass heading. We can look at light level. We can look at acceleration. But we're going to grab temperature. And I do recommend letting your students play a little bit with just viewing these different variables. Let them, after you get them to, maybe if you're following along with me, to do temperature, but also let them play around with replacing that with compass heading and twist the microbit around and see what happens. What does that look like for light level? Even acceleration, which is kind of funny when you're watching something with a slow response time show data that's a very fast response time in terms of acceleration. But anyways, let's look at temperature. So we're going to put that in there. Now the simulator obviously can't track any type of real-time temperature. So they give me this funny little bar graph that we can move up in terms of a random number or a controllable variable. So I can move this down to 13 degrees Celsius, and as you can see, it'll scroll by. Let's see what the temperature is here in my shop. So I'm going to actually download this to the microbit. And it's currently 26 degrees Celsius. Again, it's the microbit, so that might be a couple of degrees off Celsius. And that seems correct, relatively. Now we want to be able to do something with this number, right? So it's one thing to just read it and kind of walk around with this and see what the temperature is and go put this in a freezer, or don't go dipping it in water, that'd be bad, but maybe go put it outside or go put it in the sun and see what happens. If you want to talk about radiant heat, it's actually really fun to go find a piece of cement that's been in the sun for a while, and they can leave the microbit out just in the sun, but in the air, get a temperature reading, and then place it on the cement, and then you'll see it go up because of the radiant temperature, the radiant heat of the cement is much higher than the temperature of the air. Anyways, with that being said, we want to do something with this. So we want it to, let's say, display one icon if it's too hot and another icon if it's too cold. I recommend in a classroom setting, unless you want to bring a bunch of stuff in, that you're looking for if something is too hot, right? Because it's easier to warm something up in the classroom than it is to cool something down in terms of drastic cooling. Students will always be like, oh yeah, let's if it's in the freezer, it'll do well. Most teachers don't have freezers accessible to them. So we're going to say if this gets too hot, display something else, display something else. So with that, we're going to change our program. So we're going to actually remove the show number, and we're going to put it into on start. I put that in on start so that we at least get an initial temperature reading display, even in our finished product, at least once. And then I need to, good practice, I'm going to capture a variable. So I have all my old variables. I'm going to make a new one, and I'm going to call it temp. So I'm going to set temp to, what am I going to set my temperature to? Well, my current temperature I want is this temperature C reading. So I can say set temp to temperature C. I now want to do a piece of logic to this using an if-else statement. And we're going to use greater than, less than. So if temperature, our variable temperature, temp, is greater than, so notice if I bring this down, there's equivalency, non-equivalent, greater than, or less than or equal to, greater than or equal to. You can use this block for any of them. And if I remember right, it was, I can look over here. It is 25 degrees Celsius right now. So if it's greater than, let's say, 27. So I can probably heat this up 2 degrees Celsius with my hands or breathing on it, something like that. If it's greater than 27 degrees Celsius, we want it to show an icon. And let's say it's too hot. I'm just seeing if there's anything interesting. Not really. We'll just do an X. Else, so in other words, if it's less than 27 degrees, basics, show icon. You know what? Actually, let's do this. Show string. We're going to say good to go. So now it will show it once, just like the simulator's going over here, and it'll say good to go. Scroll by. If it gets warmer than that, let's say it gets up to 36 degrees Celsius, the next time it goes through that programming loop, it will show X. There's a problem. Let's see if I can get this program working on the physical microbit here. Okay, so scrolling good to go. I heat this up. Take a little bit of time. There we go. It's too warm, and I can cool it off by blow on it. There we go. It's back to good to go. I noticed that it's mirrored, so it's a little hard to read, but I can definitely tell you that it's going the right direction for me. If you had some external hardware, this is a great place to introduce the idea of music and sound with the microbit, and I'm going to show you really quickly here. So instead of it being kind of just a visual thing in terms of an output with the LED display, we can actually have it play sounds based on that. So instead of an X, we can have it play some type of alert sound. And so I'm actually going to do that, and we'll probably hear it in the simulator, and then I'll talk a little bit about how that hardware setup looks here in physical microbit land. So I'm actually going to get rid of this icon. You know what? In fact, we're actually going to leave this as an X, but then we're going to add some sound. So when you click on the music drawer, and your students will find this. I know that especially with hardware like this and incorporating sound and music into things, if you've ever been taught Scratch in a classroom setting, it is a headache. It is I call it the teacher's worst nightmare when it comes to classroom management and the amount of sound that's happening in your classroom. So your students will find this on their own. You might as well beat them to it and lay some ground rules. The simulator will actually play music for you. For them to use it with a physical microbit, they have to attach it to either a buzzer or their own personal headphones using some alligator clips, and I'll show you that circuit. It'll actually show you in the simulator. I like having alligator clips handy. Most students have headphones these days. it'll enable them, it'll actually bring the sound level of your classroom down if you let them just use their headphones rather than using the simulator. You might have to mute your Chromebooks or laptops because of that, or just ask nicely and set really good boundaries for your students. With all that being said, I'm going to have it play a melody. And let's say I have a number of options to play here. Let's do ringtone. So again, this is good to go. And you can see in the simulator, there's a headphone jack here. And using alligator clips, they have the tip of the headphone jack connected to pin 0. This is the only pin that will play music. So it has to be connected to pin 0 to the tip of the headphone jack, and ground goes to, or G and D, goes to the closest ring to the edge or the end of the headphone jack. You can't really damage your headphones, or students can't damage their headphones doing this. So feel free to let them play with it. If they hook it up the wrong way, it just won't work. So they just need to play around with moving those alligator clips around. But this is probably the easiest and best way to manage this with a class of, let's say, 20 or 30 students. So now if I raise this temperature, it'll keep playing over and over again until the temperature goes down and we're good to go again. So again, now we're talking about another output other than LEDs. It's some sound, incorporates a little bit of wiring for your students, and the alligator clip jumper wires are relatively cheap. You can get a set of 10 for a couple bucks, and then 10 would support 5 microbits. We sell them in our lab packs for the microbit as well as some buzzers. So if you're uncomfortable with students using their headphone jacks, our classroom lab pack for the microbit incorporates buzzers and alligator clips, as well as some other things. So with that, we've used the temperature variable and the temperature sensor, as well as a new output in terms of sound and music with a logical if-else statement. Now, the last thing that I want to cover really quickly is radio. It may seem complicated, it may seem daunting, but it is actually probably a lot easier than you think, and it actually makes using the microbit extremely powerful in a classroom. When you start to be able to talk about the idea of networking and communication between two devices, there's a lot you can cover with your students around that in terms of the next generation science standards when it comes to digital communication, and the idea that concept alone, let alone starting to use them in an engineering sense as well as data collection sense. So microbits have a Bluetooth radio on them, and what microbit has done is that they've simplified Bluetooth communication between two microbits, and they've called it, in general, radio. And how radio works, and we're going to write 2 programs. We're going to, as a simple demonstration that I like to use with students. It just shows the power of this. I've used it in a 300-person demonstration before, where 300 people had microbits out in the crowd, and then I did this with them, and you can literally watch the radio wave communication go out throughout the crowd, and it happened in a sea of microbits. So it's really cool, it's scalable, and works. It just plain works. And so what we're going to do is we're actually going to set up one microbit as a sender and the other microbit as a receiver. I've actually already programmed this microbit with the sender code, and we're going to go over both, but I just want to let you know the green one is going to be the sender, and the yellow one will be a receiver. But we'll go over both pieces of code. We'll go over this code, and then we'll actually write it from scratch. We'll write both from scratch, but we'll then upload the final code to the yellow microbit. So the main concept here, and this is the one thing that most people miss, is that when you're using radio with a microbit, you have to get both microbits, or whatever microbits you want to have talk, on the same radio channel. And what that is set a radio set group block. If you miss this, the microbits are going to be confused, and they're not going to be part of the same group. So think of it like watching TV. I can set my channel to ESPN or any other TV channel, and there are millions or thousands of other people watching that same channel. If none of us knew the exact channel for that given show, nobody would be watching it. So it allows us to set that channel. So on start, and this is something that we always put for the most part in on start, and we get to choose our radio group. I like to use something other than one, just because if a lot of people tend to write demo code for one, and so I always like to change it just so that there's a difference. So for this example, I'm using the number 23. So my microbit is going to be on 23. I'm actually going to change it. Let's do 3. And the next thing is, so this is the sender. So I'm going to now, what I want to have happen is I want to join this group, and when I press a button, I want to send a number 1 out over this channel. So input on button A pressed. I want to radio send number, and I want to send the number 1. Okay, radio send 1 on radio group 3. To help me realize that this is the sender, I'm going to create a little arrow icon with the show LEDs that points at button A. It helps remind me that this is what I'm going to be pressing. And that's it. That's my sender piece of code. I'm going to download this to my microbit. And I have this arrow on the yellow. Now I realize that I said one of these was the sender, one's receiver. I'm actually just going to change microbits and make the green one the receiver. Mainly, here's the reason why I'm going to be perfectly honest. I forgot which channel or which radio group I set this green one to, so that they work right off the bat. I'm going to reprogram it. So I'm going to actually unplug the yellow one, plug in the green one. So I need to remember radio group 3. In fact, I'm going to actually use this base code, leave it there, but instead of on button press, and I'm actually going to get rid of forever, I'm going to use an event block from radio. So on radio received, and there's a number of them. So there's receive number, name value, and receive string. So that's an initial filter on our radio. So it can be listening, and what it'll do is that the radio will sit there and wait until it's a number, a name value pair, or a string. So we know that we want to be listening for a number. Now we can stop here if we just want to, in terms of kind of what the number is being sent. If we're looking for just any number, we can put some blocks in here. But since we've explored if statements, we're going to actually add a little bit of logic and data checking on this. So we're actually going to check to make sure that it is the number 1 that's being sent rather than any other number. So I'm going to go to logic, if, and you know what, we'll make it an else statement. So if, I'm going to bring in the equivalency, if, and you drag receive number, so you have the receive number variable here. It does not show up in my variables drawer, so I'm actually going to grab this and bring it over. So if receive number equals 1, we want to have something happen. And what I always like to have is that it shows the icon heart. Else, we want it to clear screen. That's not very fun. How about this? Show icon. We'll do ghost. So on start, we join the radio group. Nothing should happen visibly. If we receive the number 1, it will show the heart icon. If it is some other number other than 1, it will show ghost. Awesome. So we're going to hit download. And get this onto the green microbit. So time to try this out. So I have both the green and the yellow. One's under power of a battery. That one's my sender. So if I press this A button, the heart turns on. So I got the correct number in terms of the number, sending the number 1, and it communicated via radio between these two. I know this seems like a very simple example for how to use radio, but it's also very powerful. And there's something about the simplicity of showing here's how the very basics and the easiest way of doing this works, and then let students figure out how to send, for example, their name across as a string. Or, depending on the number of button presses or the orientation of their microbit, it sends out a special or secret message to somebody else on their radio channel or radio group. It's actually really fun to do this. You assign random radio group pairings in your class around Valentine's Day, and they can share the little sugar heart messages that you can hand out. So there's a number of different projects and assignments and ways to explore radio. If you're in high school or middle school and you want to explore the idea of Internet of Things with the microbit, the radio is a really good place to start in terms of how to network these things between the two without having to dabble and jump into internet protocols and all that stuff, which is very basic networking between two devices. And with that concludes the deep dive into our programming with the microbit. I did want to take this opportunity to thank you for spending time with us and learning about the microbit, whether for doing something with your kids this summer, or if you're a teacher gearing up for next school year, either teaching it remotely, having microbits at home for your students, or doing it in your classroom when we all get back to normal. I did want to take a moment and talk about that edge connector on the microbit and the importance of it, especially for SparkFun, because it enables us to explore other hardware and other key aspects of STEM and STEAM learning outside of just what's on the microbit itself. And so we offer a number of different products that expand off the microbit and use the microbit as the heart of that in the form of different kits and boards that you can purchase. A couple of the kits are here, they're expansion kits. There's a weather station, so you can take the microbit as essentially the brain or the microcontroller and build a full-blown weather station with your students. Again, using that radio, I can actually put the weather station outside or somewhere else and then use the radio. It's usually about 100-foot range if you have line of sight, and beam that data, that weather data, real time back to another microbit that's connected to something like Google Sheets or something like that, or a data logger. We have a robotics kit, which allows you to explore robotics in a lot cheaper way than other robotics kits, using the microbit. Again, using that same ecosystem, that same programming environment of Microsoft MakeCode allows you to get up and running with robotics in a pretty simple way, as well as the MotoBit. There's a number of projects out there that you can use that with some cardboard, hot glue, popsicle sticks to build your own robot on the cheap. The Micro Arcade Kit doubles as a game controller if you want to do some really basic kind of dot matrix games on the microbit. But one of the best ways that I've found that you can use this kit is actually a controller to control a robot via radio. So sending forward, backwards, left, right commands to a robot, and basically have remote controls over that robot. If you want to do some science exploration with some more in-depth sensors and the ability to data log with the microbit, I would definitely say check out our GatorBit and Gator boards ecosystem. Has a number of both outputs and inputs all the way from barometric pressure, temperature, humidity in terms of inputs, to data logging to an SD card, an RGB LED, and a number of other LEDs that you can get off of the microbit and integrate into a project with alligator clips. For those of you in like a tech class at middle school or high school, we also offer an inventor's kit for the microbit, which enables you to and your students to start breadboarding and build more advanced circuits with the microbit as well. If you're wondering about age and grade and skill level, things like that, this chart is actually super helpful in terms of kind of the general age groups that we're talking about. So you can start using MakeCode and the microbit at a very basic level, probably about 3rd or 4th grade. Most research points at starting programming at about 3rd or 4th grade, because that is where most students start to transition from learning to read to reading to learn. Even though it's block-based programming, there is still some reading, and we can find some frustration for students in there. And so we try to say about 3rd or 4th grade and pick it up in a shorter amount of time, and then kind of increase it as you find that comfort level for your students. I didn't show it in terms of in the programming environment, but you may have seen it. You can actually switch between block-based programming and JavaScript in terms of text-based programming in MakeCode. If students have been kind of introduced to MakeCode in mid-elementary level, they'll probably be pretty comfortable transitioning to that JavaScript programming environment in middle school. But again, if middle school is their first time working with MakeCode, it might push that off a little bit. But it gives them an opportunity to start to play with it. A lot of times I call it training wheels for programming, and that I can make something in block-based, switch to text-based, see what it looks like, make a few changes, and then go back to block-based programming back and forth and see what those changes look like. You see there the tools in terms of what kits we recommend at what age groups, and then kind of skill level down below mapped to your age group if you're a parent looking at this, or maybe an after-school program. In terms of the things that SparkFun offers beyond our products, experiment hookup guides. Each of our kits have an in-depth experiment guide, so that there's basically a tutorial for each sensor or each actuator or different things that you can do with the kit. And then over time, we've been releasing more videos, example projects, things like that, or using the microbit ecosystem. So always be looking at those, updating those. We're always updating them and producing new ones over time. We also have a microbit video series and a number of concepts and how-tos in terms of video format as well. And with that, thank you so much for spending time watching this video. If you have any questions, again, please leave them in the comments of the YouTube video here. We'll definitely be keeping an eye out for them and answering them as they come up. You can also email us at education@sparkfun.com if you have any more questions about product or even technical questions. So thank you again, and hope you decide to incorporate the microbit into your classroom at some point.